or as a part of the ECMO circuit, either before the oxygenator it can be connected. So in various ways it can be integrated with the ECMO circuit, which we will be subsequently seeing. You can just demonstrate the alarms.
So good afternoon. So basically, the circuit which we are going to demonstrate is there is a blood circuit and there is a non-blood circuit. The blood circuit volume is 116 ml. It is very important for these patient with like patient who has a less volume or the pediatric patient. The volume of blood circuit is 116 ml and followed by the dialyzer circuit, which dialyzer blood volume, which has a volume of 100 ml. 116 plus 100. So the similar way we have a, like for pediatric patient, we have a lesser volume of circuit available. Like the patient who has a 8 kg or 8 to 16 kg, we have a different circuit which has a lesser volume, let's say 74 ml, 18 plus 56 is the volume. And similarly, the patient who has more than 80 kg or above, we have a other circuit which has a higher volume because the volume of that particular patient is higher. And as sir has mentioned, there, using that circuit, we can integrate other adsorbent column like you have seen cytosol, this polyvaccine B, then HL330, that filters can be easily plugged in that. And that machine can be integrated with the ECMO with different circuit configuration we can plug with. Moving towards the circuit priming, so हाथ से तो फिर so as sir has already mentioned, we have a 4 component. This is the arterial line, filtrate or effluent line. This is for substitute, this is for dialysis, and this is our dialyzer. Dialyzer, like as I mentioned, as per the body weight of a patient, accordingly we decide. The dialyzer is this is a hemo filter or ultra flux filter. It has a surface area of 1.4 meter square. It's a negatively charged membrane with hydrophobic nature. So not hydrophilic, unlike to other membranes. It's a hydrophobic membrane which repel the fluid from the membrane. So let me start the priming first. So this is the So this is not the low flux. It's basically ultra flux. It's more than the flux. Basically, the basic difference between this filter and any high flux or ordinary high flux filter is the pore size in this filter is bigger, but number of pores are lesser, because the agenda in CRRT is basically to remove the molecules in slow and gentle manner. So we never denote these filters in terms of flux, but though these are the high flux filter, even more than that. These are the ultra flux filter. And the membrane is polysulfone.
Filters are generally high flux filters.
We use high flux filters only.
There are 2 terminologies only. One is flux, second is cutoff. Flux determines the amount of ultrafiltration which is done per unit of transmembrane pressure. Low flux, medium flux, high flux. This is high flux. Cutoff determined by the molecule which can be removed. So low cutoff, medium cutoff, high cutoff. So high cutoff membranes are TheraLight, which can remove the light chains also, which are more than 36,000 Daltons. Medium cutoff are beta 2 microglobulin, which is 12,000 Daltons. Low cutoff, we take urea as a low cutoff, 500 Daltons. So this is high flux, medium cutoff. F6 is low flux, low cutoff. More than high cutoff is plasma, which will take the sieving coefficient for albumin for a plasma filter is 1. Whatever albumin you give it, takes it out. So cutoff is a different terminology, flux is a different terminology. This is high flux, medium cutoff.
So this has a capacity to remove 30,000 Dalton toll. So as rightly said by sir, it's a MCO dialyzer, we can say. It can have capacity to remove even myoglobulin and inulin also, which has a molecular weight more than 17,000 Dalton. So this is the, basically we just set it the circuit. We are doing CVV HDF pre-dilution. So I will demonstrate you, we'll set the circuit for CVV HDF pre-dilution, and followed by this we'll let you know how we can turn CVV HDF to pre-CVV HDF to post-CVV HDF, or CVV HDF to HD, CVV HD, or CVV HF. So using single circuit, we can switch and to the any kind of therapy which I mentioned. So this is the arterial line we plugged into the saline, you will see, and followed by this is the arterial pressure. Arterial pressure basically axis pressure. The pressure from the cannula we are taking blood, that has been measured by this. Here the arterial pressure is nothing with the patient. It is just to check the integrity of a arterial line, whether the blood is coming smoothly or not. If the more pressure is rising, that means the cannula is not placed well. Probably the tip is touching in the vessel. We have to take care of that circuit. Followed by that, this is the pre-filter pressure. If there is a problem in the circuit, or there is a membrane choking, or there is a high axis pressure, there will be a pre-filter pressure raise. From there we will check it. Then this goes to the filter from the downside. Since we are doing priming, we kept the dialyzer on the opposite direction, because we are filling the dialyzer from down to upside. So blood is filling, the saline is filling from down to upside, and followed by, this is the return line. From there, it is coming. This is the post dilution port. We'll let you know what is post dilution and pre-dilution. And this is the axis pressure line, or return pressure line, or venous pressure line. Like if it's rising, that means there is some problem in the return pressure, or there is some obstruction, kinking, or clotting in the return pressure, we'll see. And this is the air trap. If there is any air, it comes in the circuit, extracarpal circuit, that can be diagnosed, or that can be checked by the machine, and it will give air bubble detector alarm. And this clamp is responsible not to pass the blood into the patient body. It's a venous occlusion clamp. And followed by this, it will again return to the patient. Since we are doing hello, yeah. So since we are doing priming, it's just collection bag. Once we'll connect the patient, it will directly go to the cannula on the venous return line. So machine is self-explanatory in terms of how to place the circuit. So let me start with the beginning. I just on the machine and put the machine on functional test. Once machine done their all test, functional test passed, we'll select the mode. We select CVV HDF pre-dilution. Once we select CVV pre-dilution, whatever the mode we are selecting, with the same flow, the diagram of that particular therapy will develop. Let's say we have done the CVV HDF pre-dilution. This will demonstrate this is the venous line we have to place first. We have placed it, followed by next. Then arterial line will place it. It has been placed. Third step, we have to place filtrate line and dialyzer. It has been placed. And followed by the two bags on the back scale, it has been placed. And this is the dialysate and substitute line. It has been placed already. Once we, and this is heparin. 90% of CRRT patients are basically heparin free we used to keep. If we want to keep low heparin or with heparin, so this is the heparin line, we can place it via this heparin pump. Or dose of heparin you can set from there. We'll show you afterward. And this is the entire circuit with the color-coded graph. You can see this is the written blue one. This arterial, the axis pressure, filtrate pressure, dialysate substitute, heparin and dialysate substitute. And color-coded you will see. Let me say OK. And once I say OK, machine will automatically take the things out. OK. So pre-filter pressure down not correctly. Just a second. Okay, since we forget to install this pre-filter pressure dome, so machine is giving alarm. Once I plug, confirm it. So since we have not put heparin line, it is, we will say no to the machine, because we are not putting a heparin syringe on that, and we'll start priming. Now machine will do everything on its own. You don't require to unlike to conventional dialysis device where you have to many times remove the air and everything you have to do. There is no requirement in terms of increasing or decreasing the blood flow, turning the dialyzer from one way to other. This is not required. Machine will automatically, it is auto programmed, auto run, it will do. And here you will see the dose prescription. Okay, heater bag is not corrected. So, okay, done. Confirm it. And here the prescription you will see, probably sir will let us know how we'll set the prescription. This is the net ultrafiltration, rate of substitute, rate of dialysate, blood flow, heparin, how much bolus we want to give. This is for the temperature of dialysate and substitute both, and followed by the, in case during therapy, let's say you want to give some fluid challenges, or the patient landed into hypertension, you want to give some fluid, from here you can give bolus. So once we turn on the machine and till we'll connect patient, it will take at least 20 minutes to prepare the entire circuit. Before that you cannot start it. It has on time, prefixed time, 20 minutes it will take. So mode we have selected is CVV HDF, and with heparin we are doing. Other than that, as in the beginning you have seen, we have a conventional CRRT mode, advanced mode like calcium citrate CVV HDF, calcium citrate CVV HF. Then therapeutic plasma exchange and pediatric CVV HD and CVVH can be done in that. So it is taking their own time, in the meantime, we can discuss about the parameters of effluent, probably, so if you can get us through. What is effluent and how?
Were already discussed in the morning sessions, so it depends a lot upon the hemodynamics of the patients as well, and the effluent dose that we are targeting. So unlike in hemodialysis where we have KT/IV as a tool to monitor efficiency of dialysis, adequacy of dialysis, so here it goes with the effluent dose. So on the basis of that, we need to calculate the dialysate and the substitute and the replacement fluid. And in a usual adult, let's say it's the blood flows are kept around 150 to 200 ml per minute, at least not less than usually 100. So that's a usual blood flow, and depending upon the modality that we are choosing, whether it's CVHD or HF or HDF, so that will determine the type of effluent and the dialysate that we are going to set in this machine. Like here they have set around 1000 ml per hour of substitute and dialysate of 1000 ml per hour. So the calculation, I think we had already discussed in the morning as to how it has to be divided between the dialysate and the replacement. So that's how the settings for that will come. And the ultrafiltration, of course, needs a periodic reassessment of these patients. But in what we routinely see in our ICU practice is that hourly monitoring of these patients becomes practically difficult. So cumulative balance is what we get to see. And like at the end of 6 to 8 hours, we have to kind of do a little bit of more of ultrafiltration and then catch up on the fluid accumulation that has happened. So if possible, a hourly monitoring and adjustment to be done. So that depends upon in which phase of sepsis or illness the patient is, whether the patient is in the resuscitation phase or in the stabilization phase, or you want to de-resuscitate the patient. So the fluid goals would depend upon that as well. So in somebody who's in the resuscitation phase, you would not be willing to do a lot of ultrafiltration. So if somebody who's in the stabilization phase, you just want to replace whatever is being given inside. For a de-resuscitation, you would aim for net ultrafiltration. So now coming to the calculation of net ultrafiltration, so it depends upon the modality. So if it's CVV HT, we need to take the ultrafiltration and also the dialysate flow. So together that has to be taken to calculate the net UF or the dialysis dose. And if it is in the CVV HDF, then it will also include the replacement fluid. So together that will contribute to the net effluent dose. That's something which we need to keep in mind. So based on the calculated dose, we need to divide it and divide it between the dialysate and the replacement in the case of a CVV HDF. Or if it's just CVV HT, then we need to keep it for the dialysate per se. And the UF we need to set. So here they have.
It is possible.
That can be done. Yeah,
It is possible. So maximum rate of dialysate and substitute, we can keep it, for substitute we can keep it 9.6 liter per hour, and minimum is 600 ml per hour. And in terms of dialysate, we can do 4.8 liter per hour. And in terms of ultrafiltration, 2.5 liter per hour maximum ultrafiltration you can keep, though practically not possible 2.5 liter because patients, such type of patient are so sick.
Having said that, what we follow in our unit is we usually divide that if it's VRT, we usually follow CVV HDF. So that's a common modality that we do. So we divide it between the dialysate and the replacement and give 50% pre and 50% post, and then reassess after 6 hours and then decide as to how any modulation has to be done. If the patient is on pressors, we usually don't keep do a net extra ultrafiltration initially for the first 5-6 hours, and then once the patient is stable, then we start adding ultrafiltration and then reassess the patient periodically. So you're telling something. The cost of
the
circuit comes to around 15 to 25,000 between both the brands. If we say, like the Baxter Prisma Flex kit comes around 15-16,000. So in the government sector, that's what we are getting.
Inclusive of the filter?
Inclusive of the filter. It has the filter in itself. I think their set is a little. They should be able to say.
Yeah, so the entire cost including filter, it will be 15,000 rupees, and that exclude the fluid. The fluid basically this, the 5 liter solution bag, that will cost you somewhere around 2,800 rupees. And let's say you are doing 1 liter per hour, each dialysate and substitute, you will require 10 bags a day. So this is how you can calculate it. 10 bags per day we required. And the life of circuit is 72 hours. This filter can last for 3 days, including circuit, in normal course, if it's not getting clogged. And this 1 bag cost is 2,800 rupees.
So roughly 50,000 day one it will come. And probably on subsequent days, just for the fluid, 30 to 40,000 it may come.
You better.
The aims actually for the below poverty line, we are giving the fluids for free. Fluid for free. The kit is to be brought. Yeah, kit has to be brought.
उसमें से रीसर्कुलेशन कनेक्टर निकाल दो उसमें HDF ट्यूबिंग में से.
Then as per the per kg body weight, do you have that 20 to 50 ml per kg or any?
That's the recommended effluent dose.
एक IV set
Usually the prescribed dose should be higher because the delivered dose is usually lesser than the prescribed dose. So you keep it around 25 ml per kg. So that's the usual dose.
25.
It depends upon the etiology of sepsis, and if you're having a hypercatabolic state where you need a higher flow, then you need to, of course it's not like a fixed thing. We do modulate depending upon the kind of injury which is causing the renal shutdown.
A patient who is hypercatabolic,
We may go a little higher up, is 35.
but at the same time he is hypotensive as well.
Yeah, so basically most of these patients are on multiple pressors. So the net ultrafiltration is something that we could control on, and depending upon after the stabilization, the ultrafiltration could be slowly added on. So because whatever we are giving, we are going to remove it. So the net effect on the hemodynamics should not be much, depending upon the volume per se that is being depicted.
Perfect. Thank you. आ गया. Sorry. So this is the machine has been now prepared. We have taken machine in treatment mode. So like as far as this parameter is concerned, we have set 10 ml per hour of ultrafiltration, 600 ml substitute, and that substitute is basically pre-dilution we have kept, and 600 ml is the rate of dialysate. So I am considering this patient has a less body weight. That is the reason 6 plus 6 plus 10, 1200 ml per hour, 1210 ml per hour rate of basically effluent we are giving through. And this is, since we are not giving heparin, we kept heparin off. And this is the balance. Balance is something like how much negative you are doing. How much negative ultrafiltration you are doing, that is there. Treatment time is 0, 0. Once time increase, you will get like 1 hour, 2 hours. As I mentioned, the circuit life is 72 hours is normal course. These are the pressures or trending graph you will see. Like what is the arterial pressure, venous pressure, or pre-filter pressure. If it's increasing or decreasing, you will see. Once it develop over a time, you will see the pattern of graph. This is what we were talking about. This is the arterial pressure. Since we have not taken any patient, so it comes in the positive, but arterial pressure, since we are taking blood out from the body, it always kept in negative. And it should not go beyond negative 250 millimercury. So this is arterial pressure. And it is one of the most common alarm which used to come in CRRT is low axis pressure or low arterial pressure. So let me show you, let me demonstrate you. Let's say this is our patient. We have kept in recirculation, and this is the arterial line and this is the venous line. This is the axis line and this is the return line. So let me clamp it. You will see the arterial pressure, it will be more negative. And you will not rectify it if you are not removing this. If there is a problem in arterial axis, or your catheter is not placed well, or catheter is good, some vessel is touching on the tape, there will be a more negative pressure or more arterial pressure or axis pressure will come. So high axis pressure. Let me on it and it will come accordingly. You will see the arterial pressure will come out. So this is one more alarm. It used like very common in CRRT patient because these patients are very low BP. Vasocontraction will be there and probably this may lead a problem. Then this is venous pressure or return pressure. Return pressure is belong to the return line. Let's say this is a patient and this is a return line. If something has happened in the return line, it can be kinking, it can be clamping by accident, or it can be clot in the venous chamber. It will lead a higher venous or higher axis pressure, higher return pressure. So let me show you how it comes. This is the venous pressure. Let me clamp it. I clamp it. You will see this will come up. The venous pressure, it is coming up. And high return pressure alarm. And once I release this or once I rectify it, this will, and you can see the spikes in the graph. The pressure is rising and spikes will be there. So this is the return pressure or the venous pressure. And third one is pre-filter pressure. So pre-filter pressure is measured from this dome. Anything has happened which leads a higher pressure, before filter, it will reflect in the pre-filter pressure. It can be kink or clot in the venous header like this. I am kinking it. You will see venous pressure will come up because this is coming on the filter, and since it's not passing filter, before pressure will increase. So this low TMP and pre-filter pressure will increase. So this is pre-filter pressure. Along with that, blood leak I cannot show you because we do not have blood. This is a blood leak sensor. If this is an effluent line, if let's say by accident or by something day 2 or day 3, our membrane get ruptured, there will be a RBC stains. RBC will come and it will detect by this, and you will get BLD alarm, blood leak detector alarm, via this. So this is called blood leak detector. Sometimes in acute liver failure where the patient who has a high bilirubin, sometimes we have seen, because effluent comes in more yellowish in nature, more concentrated, that time also it used to check it. So we have a feature, that time we can off the blood leak because it's a limitation. So there we can sense it. Then other than that blood alarms, there are some system related alarms. Because of something has happened on the scale, or someone has put weight or some curtain or some devices touching on the scale like this, which I have done, it will give error on scale 2. This is scale 2. So once I remove this, this will goes. Similarly for this, and same with this. So okay, this is coming now. No blood is detected. So this is because of, basically machine is designed on gravitometric scale. Whatever is removing from here, and whatever is removing from the blood in terms of ultrafiltration, A plus B plus C has to come here. If it's not coming, this will not work, or this will not, it will give alarm. So there is no hydraulic inside the machine. There is no water requirement, there is no drain requirement. It is whatever on the scale 1, scale 2 and ultrafiltration is removing, it has to be calculated over there. If it's not communicating well, we have to, there is something or external pressure. It can be air also. So it is always advisable, once we are running this machine, it is always advisable, it has to be away from the AC duct, or direct ceiling fan should not be there, because some air pressure can even deviate the machine scales. So these scales are so sensitive in terms of that. Then in menus, we can have a care mode. In care mode, if we switch machine on the care mode, so the blood pressure will come down, the blood pump will come down with the 40 ml per minute, and all pressure range will be more wider. Care mode is basically, let's say you have a patient in day 1 or day 2, you have to give back care. They are sick patients. So during back care, you have to tilt the patient from one way to other, and giving back care, the catheter repositioning may require, or and that time machine will give lot of alarms. To prevent such situation, we can put a machine on care mode. It is a 6-minute program. During that time, machine will not give any alarm, and it will be a minimum blood flow, so that if there is any resistance in the cannula during positioning of patient, it can be managed. So this is a care mode. Once it's done, you can do continue, and this will remove. So this is care mode. Even let's say we started with CVV HDF pre-dilution, and started with CVV HDF pre-dilution in day 1. Day 2, you are assuming we do not require substitute now, because we want more gaseous correction, metabolic correction, and urea creatinine to be removed. So we do not require a substitute. So we can switch off the substitute. Now you will see This is the dialysate, this is substitute. Substitute pump will not work, only dialysate and other pump will work. And machine will be CVV HD mode. And vice versa is also possible. Let's say in day 3, you will see we don't require dialysate. So we switch on the substitute and kept the dialysate off. So now this pump will stop and all 3 pump will work and machine will be on CVV HF mode. Only convective based therapy, middle and large molecule toxins we are removing. So like CVV HDF to CVV HF, CVV HF to CVV HDF, or CVV HF or CVV HDF. This we have kept CVV HDF post dilution. You want to switch to pre-dilution, which is more common in heparin free cases. So this is the switch to pre-dilution. We'll switch off and from there we remove it. Sorry. And okay, so this is not the right way. We have to stop it, then we have to stop the pump and we have to do it. So these ports are basically one-way thing. You can give something, you cannot take from that. This is pre-dilution port, this is post-dilution port. So you just stop the pump and you can switch to pre-dilution and to the post-dilution. So this can be done from here. In CVV HDF, either pre or post you can do. In CVV HF, pre and post together you can manage. Pre and post together you can manage in CVV HF. Moving to the next, which is most common mistake user or SCP used to do during, let's say, the bag strength is 10 kg. Let's say it is filled. They used to, like, directly they remove it and they throw or they empty the bag. So it is to be done via program only. You'll see, you will go in the menus and there will be a, just a second. So it is communicating again since we are playing much. So scale test is doing. So since the scale has a capacity to hold 12 kg of weight, which means at one go in single time you can place 2 bag or 10-liter solution in one go, which means you don't require more frequency, you don't require more frequently bag need to be changed. It's like that only. Let's say you are keeping 1 liter dialysate or 1 liter substitute, 1 liter dialysate or 1 liter substitute, every 5 hours the bag need to be changed. It's like that. But if you kept 10-liter bag in one scale, for next 10 hours you don't require to change it. So it is communicating scale test. So that is the reason bag change is not coming. So I want to cost. So it is somewhere 18.5 plus GST. No. So it's just we required power plug, 16 ampere power plug, and you can start. Cost is negligible. So actually I am little dicey because we are not the commercial guys. They will let us know much. Okay, just देखो 3 4 में. Actually this is, there is a movement. Okay, there is a movement on the scale. You can see that there is a movement on scale. It is by which it is. Yes. So at a time. This is a 5-liter bag and this is a connector. Via this, there is no spike adapter we required. Again, tubings can directly plug. These are Leo lock connectors. You can break the con from there and you can place it. At a time, 2 bags on one scale you can place, so that lesser frequency of bag change you require. Because why we are so particular in this case, because once you are going to the bag change or once you are stopping the treatment, it is basically interrupting the treatment and it increases the downtime. So that is the reason. Sorry? Both. No, actually, CRRT, even we do not know how long it will take. Usually, CRRT is only benefited when it is running more than 24 hours. Even you will see by theoretically, by definition, it is like that only. Any extracorporeal device which is intended to replace a native kidney over and above period of time more than 24 hours, that is called CRRT, and that is the reason we recommend. It has to be run at least more than 24 hours. Then it is defined as a CRRT. So one scale is for dialysate, one is for the substitute. And so, okay, let me stop it. Let me go in the bag change. Let me show you how the bag look likes. So these are the 2 spikes. At one go, we can connect dialysate on this and substitute on this. 2 bag on each. Like this, we can do it. It's 10 kg each. So each scale has a capacity of 12 kg. Each scale. 10 plus 10, 20. And the maximum capacity is 24. Yes. So yeah, you can even see, okay, sorry. Even you can see how much fluid is remaining. 578 gram on scale this, 774 gram on scale 2. You will see like this, these scales are so sensitive, even I am putting this, it will sense 1 gram. So the scales are so sensitive in terms of weight, even they can, 1 gram of weight it can sense. So once you want to change the bag or you want to empty the effluent, you have to go in the bag change, and this pop-up screen will come, and after doing your removal of the fluid and changing the bag, you have to go exit, and then it will again recommunicate and you can do it. Yes, that's what I was showing. So scale imbalance alarm only comes if I would place some additional weight like curtain or hand or something like that, then scale balancing error it will show. Or you have seen this bag, effluent bag has, like, it is touching with one blood tubing. That time you have seen there was a scale 3 and 4 has an error. So if any additional force which is working on the scales, bottom and up, then this error on scale will come. Or you are without commanding a machine or without knowing the machine that you are changing a bag, then it will come. Then it will come.
And the bags can be reutilized, like sometimes we are changing from 2K to 0K. And there is a partially utilized bag, and it can be reapplied, right?
Yes, you can do it. You have like, there are 2 ways. One is the best measurement is like you want to use 0 to 2K of solution. So let the 0K of solution empty first, and then you can put another 2K of solution.
No.
If not,
What I'm asking is, we've switched from 0K to 2K.
Yes.
And then after a while, I want to go back to 0K. So that bag which was partially utilized,
It can be
I
used.
can
It can
utilize
use.
again.
It can be used. Only
And
thing
I
you
like
have
to change both the bags simultaneously.
it's up to you. Like you want potassium in dialysate or you want potassium in substitute. It's up to you.
Right.
Usually, no, nothing. Change volume. See, so this software work in a way, once we go in the bag change, this weight you can see. And if I am removing this and putting new bag, it start calculating again. It calibrate the entire circuit. So this works on that way. It will show you, see, the communication between scale 1 and 2, it is being checked.
So both the bags are dialysate bags and replacement bags at the same time?
It's up to you again. Let's say you are keeping more dialysate and less substitute. You want more diffusive clearance, less convective clearance. You are keeping 1.5 liter dialysate and 600 ml substitute. So the bag who has a more consumption will empty more.
Sir is asking whether you can utilize the same bag for dialysate as well as replacement. Right?
Is it okay?
So that is for a heparin CRRT. If you are doing a citrate CRRT, you have to use a calcium-free dialysate only, which is a Sika bag.
Yes.
Okay, Sika will be a mandatory dialysate. You can't use another calcium-containing dialysate. But for these are multi-big solutions. The multi-bigs you can use either as dialysate or replacement. So it's up to us to for a permutation combination. If you want 2K, so multi-bigs will come as 0, 2, 3, 4.
Yes.
It will come all sizes. So you want a replacement with 4, you put it as 4. You want less in dialysate, you put 0K as. So if you want a more potassium clearance, you put both 0.
Yes.
Replacement plus dialysate. So the potassium will go out fast. But if you want to contain the potassium little slower, so you replace little potassium with say 2 and put the dialysate at 0. So the gradient will not fall quickly. So for heparin, any bag, okay. But for citrate, calcium free. Yes, yes. For Baxter, the dialysate bag is bifossil, which is calcium free. It contains magnesium though. So magnesium is also a divalent cation. So it also neutralizes some amount of citrate. But yes, yes, yes. But sometimes what we do, we put in a normal saline, 1 liter, and we add some magnesium to it and give it as a post-filter replacement, just to counter the hypomagnesemia. So it's but there is a hangers. This is not gravitational. There are some other mechanism. We have to weigh them. So it's weight sensitive for Baxter platform. These are all volumetric. These are all gravitational, right? These are gravitational. So the way we are measuring the fluid infused and the fluid taken out are different in two platforms, but they serve the purpose. So they are sensitive to an extent of 9 ml. The standard error is only 9 ml, not beyond that.
So this is what we are demonstrating. This is for heparin or without heparin circuit. So we have a similar circuit configuration for Sika, RC, renal citrate anticoagulation or calcium citrate anticoagulation. For that, the solution we are using, it is different from that. It carries, as sir has mentioned, 0 calcium, and potassium is, we have 2 variants, 0 and 2. And magnesium we already have is 0.7 milligram, and phosphate also. So this is for either with heparin or without heparin. But for Sika we are following Berlin protocol. That Berlin, in this interface you will have one more value of calcium and citrate. So accordingly you can, we have a 2 more bag. The solution bag for citrate named as a Cefovin, and for calcium is known as a Calratia. It's a calcium chloride.
So Cefovin is the trisodium citrate 4% and Calratia is a calcium chloride. So we can give. So this is, and it is as per the post-ionized calcium. This is the post-ionized, like from there we can take the sample of after dialyzer blood sample, how much calcium, and accordingly we can take a call how much calcium we want to go or how much. Let's say it is increasing by or decreasing by 0.5 milliequivalent, we will increase the dose of calcium, and vice versa also can be done. So there's a protocol, but it is a software driven, so beautifully designed. You can increase the dose of calcium or decrease the dose of calcium, and with respect of that the rate of citrate is accordingly adjust. No, किसी भी machine में नहीं मैम. No one machine has made in a way it automatically like measure. We have to send test to the biochemist, then we'll be able to check it. Machine will not check anything. Yes. So other than that, we have this ECMO. So we can integrate this with the ECMO. There are 2-3 types of configuration. The best combination is before and after oxygenator. Like artery will connect before and venous. So this is the best. Probably he would able to see.